Well, here are the answers to problem set chapter 3, which is motion in two dimensions. And this is where you come across vectors and how you have to resolve vectors into two components and use them to work out the problems. Vector addition, if you have two vectors, vector A and B, if you simply add their ends together, you get the sum of the two vectors. This first question talks about walking 18 meters straight west and then 25 meters straight north, and how far are you from your starting point? Now that's your starting point. How far away are you? So that's simply the vector, which is the sum of 1 and 2. Okay, so that's 18, 25, and looking for AC, and use the Pythagorean theorem to find that. You get it as square root of 949, which is 30.8 meter. Now to find the angle, take tangent. Tan is opposite side by adjacent side, which is BC by AB. Get 1.388. Take the arctan of that, you get 54.2 degrees. So the magnitude of the vector is 30.8 meters, and it's at 54.2 degrees north of west. The second question, you have two velocities, VA and VB. Find the components of these along the x and the y axis. Okay, I think we'll skip this second question and go straight to the third one. In this question, you fly 32 kilometers in a straight line in still air in the direction 35 degrees south of west. So 32 kilometers. 35 degrees south of west. So that's the west direction, and so this is south of west. Therefore, this angle must be 35 degrees. Find the distances you would have to fly straight south and then straight west to arrive at the same point. So instead of going this way, you could have gone straight south and then straight to the west. And you're asked to find these two distances. That's part A. So that angle is 35, this is 32 kilometers. So all you have to do is find the components. And since that is 35 degrees, you're going to get this angle is also 35. So this angle is also 35 degrees. And therefore, when you break this into AX and AY, AX is going to be 32 cos 35, it's 26.21 kilometers, and AY is 32 sine 35, 18.35 kilometers. So that's the answer to A. Now B, find the distances you would have to fly first in a direction 45 degrees south of west, and then in direction 45 degrees west of north. So first you fly, all right, so I'm just trying to show you what 45 degrees is there. So first you fly 45 degrees south of west, and then 45 degrees west of north. So west of south, oh, that's west of south, and that's west of north. So from this diagram you see that because the initial angle was 35 and now it's 45. The difference is 10 degrees. That's what I'm trying to show from this diagram. That angle is going to be 10 degrees. And once you know that that angle is 10 degrees, you can find out these components. It's 32 cos 10 and 32 sine 10 degrees, which is 31.51 and 5.56 kilometers. Now do not spend too much time on this problem. Let's go straight to the next. This one says a projectile is launched at ground level with an initial speed of 50 meters per second at an angle of 30 degrees above the horizontal. Strikes a target above the ground 3 seconds later. What are the x and y distances from where the projectile was launched to where it lands? So that's how the projectile goes. Okay, now the diagram is right. It strikes a target that is a little bit above the ground, so it strikes it here. So there is a y displacement and there's also an x displacement, right? The velocity is 50 at an angle of 30. First of all, the components: 50 sine 30 along the vertical, and that's 25, and a is minus 9.8 meter per second squared. Time is given as 3 seconds. We can find the vertical displacement using this equation. That is 75 minus 44.1, which gives you 30.9 meters. Now, to find the x distance, remember the horizontal velocity is a constant. It is 50 cos 30. It's a constant, so the only equation that you can use is multiply that velocity with the time. 43.3 multiplied by 3. It's 129 meters. The fifth one. A ball is kicked with an initial velocity of 16 meters per second in the horizontal direction and 12 in the vertical. You see, now in this case, both the components are given. And you got to find this, at what speed does the ball hit the ground. You got to understand that with whatever speed the ball leaves is exactly the speed at which it's going to hit the ground. That means just before it hits the ground. So just find the resultant of what's given, which is 16 and 12. And you know that AC is just going to be square root of AB squared plus BC squared, and you get it as 256 plus 144, which gives 400, and the square root of 400 is 20 meters per second. The B part says that for how long does the ball remain in the air? Now for this we only use the vertical component. So, and the vertical component is 12 meters per second, correct? A is minus 9.8 meters per second squared. Delta Y is 0 because it lands back on the ground. We have to find the time. Use this equation. Carefully switch sides, cancel out 1t from each side, and so time is 12 divided by 4.9, 2.45 seconds. In the C part, you have to find the maximum height. Now to find the maximum height reached, remember that at the highest point, the final velocity is 0, correct? So again, you start with the vertical initial, which is 12, but now we know that the final velocity is 0. Therefore, the equation that we're going to use is this one. And when you substitute and calculate, You get the maximum height as 7.35 meter. Sixth one, an archer shoots an arrow at a 75-meter distant target. The bullseye of the target is at the same height as the release height of the arrow. At what angle must the arrow be released to hit the bullseye if its initial speed is 35 meters per second? Let's get the diagram. All right. Now, surely, this guy has to release it at an angle theta as shown so that it goes and hits the target, right? So you got to find the angle. This distance is 75 meters and VOX is 35 cos theta. VOY is 35 sine theta. We know that. Delta X is 75 meter. Delta Y is 0 because it hits at the same level. And A is minus 9.8 meter per second squared. Can we find the time? Yes, we could. Using this equation, substitute into that. There are two unknowns there. Cancel out one of the t's and you get this as one of the equations. And then we go to the x component. We know that for the x, velocity is constant, so displacement is velocity multiplied by time, from which you get cos theta. So you get equation 1 and 2. If you multiply 1 and 2, on the left hand side you get sine theta times cos theta. And on the right side, you multiply these two terms, the t's cancel out, so you have sine theta cos theta is 0.3. Now there is a trig identity which is 2 sine theta cos theta, because sine 2 theta can be written as 2 sine theta cos theta. So what I did here is just multiply both sides with 2. So there's a 2 there, as you can see. And this side became 0.6. Because 0.3 multiplied by 2 is 0.6. Now why did I do that? Because I know that this can be written as sine 2 theta. Alright, so sine 2 theta is 0.6. From which 2 theta is sine inverse of 0.6, which is 36.9 degrees. That's 2 theta. Therefore, theta is half of that, 18.4 degrees. Which means he has to shoot it at an angle of 18.4 degrees. There is a second part to this question. There is a large tree halfway between the archer and the target, with an overhanging horizontal branch 3.50 meters above the release height. Will the arrow go over or under the branch? Now we got to do is find the maximum height, because at halfway we know it's going to go at the maximum height. Okay, so at the maximum height, like in the last problem, we know the final velocity is 0. We can use this equation and find the time by rearranging. Well, no space, so I'll have to write over this, but I get it as 1.13 seconds. Okay, so the time is 1.13 seconds. And at this time, what is delta y? Delta y would be the vertical component of the velocity, right? So we can use v naught t plus 1/2 at squared. V naught is the vertical component, that's the initial, which is 35 sine 18.4. And when you substitute, You get 6.23 meter, which means the arrow goes over the branch. Because remember, the branch was only 3.5 meters above, so the arrow goes over the branch. Bringing us to the seventh one. In a standing broad jump, one squats and then pushes off with the legs to see how far one can jump. Suppose the extension of the legs from the crouching position is 0.6 meter and the acceleration achieved is 1.25 times the acceleration due to gravity. How far can they jump? In this case, we have to first find the launch velocity. So that is the velocity at which the person just takes off. The initial velocity is 0. It starts from 0. And we can find the final velocity using this equation. You see that the initial velocity is taken as 0, but 2 times the acceleration is 1.25 times 9.8 because that's given. So you get the velocity of launch as 3.83 meter per second, and the maximum distance is obtained when the person takes off at 45 degrees. So that's a fact that is known. Therefore, the vertical component of the velocity is 3.83 sine 45. Acceleration is minus 9.8. Delta y is 0 because he lands back on the ground, and find the time. When you use this equation, you get the time. And see, I know I'm going fast, but you can pause and look at it, and that's why I'm going fast. And you get the time as 0.553 seconds, and from there you can find the displacement along the x, multiplying it with the horizontal component and the time there, and you get 1.5 meters. Okay. Now, here is a question where an eagle is flying horizontally at a speed of 3 meters per second, as you can see. When the fish in her talons wiggles loose and falls into the lake 5 meters below. Calculate the velocity of the fish relative to the water when it hits the water. Alright, important word, the eagle is flying horizontally, so therefore its initial vertical velocity is 0. Well, it has a horizontal velocity of 3, but its initial vertical velocity is 0. Acceleration is 9.8. Delta y is 5 meters. It says it falls 5 meters below. Find the final velocity. Okay, so you can use this equation and you get the final velocity. That's the final vertical velocity. 9.9 meters per second, but it also has a horizontal velocity which never changes. So it was 3 and it's always going to be 3. It's still 3. So you have a vertical and a horizontal, and you got to find the total sum of the two using the Pythagorean theorem, and you get it as 10.3 meters per second. That's the velocity of the fish. Right. The ninth one, a seagull flies at a velocity of 9 meters per second straight into the wind. If it takes the bird 20 minutes to travel 6 kilometers relative to the earth, what is the velocity of the wind? We'll take one part at a time. So the notations here, velocity, velocity of the seagull with respect to the ground, velocity of the seagull with respect to air, plus velocity of the air with respect to the ground. Because the air is going to carry it's flying straight into the wind. Remember that. And therefore the velocity of the air with respect to the ground is the difference and velocity is displacement divided by time. 6 kilometers is being changed into meters, so that is 5 meter per second. Therefore the velocity of when you substitute these values there, 5 minus 9, you get minus 4 meter per second. Of course, the wind is going against, that is why. But in the B part, the bird turns around and flies with the wind. How long will it take to return? Now he's flying with the wind. Therefore now the same equation, but you see that there's a negative there because of the opposite direction. With the wind, he's going to have a higher velocity. That's common sense. So that's 13 meter per second. And therefore, it's going to take less time. Same distance divided by the new velocity only takes 462 seconds now, which is 7 minutes 42 seconds. And discuss how the wind affects the total round trip. Oh, surely the wind always slows down the round trip. So it was better if there was no wind at all. Interesting question, because remember that it was flying into the wind. It took 20 minutes because it was fighting the wind. But when it was going with it, it only took 7 minutes 42 seconds. Here you have two vectors again. A ship sets sail from Rotterdam, the Netherlands, heading due north, at 7 meters per second, relative to the water. The local ocean current is 1.5 meters per second in a direction 40 degrees north of east. What is the velocity of the ship relative to the earth? Okay, let's draw the diagram. Heading due north. So velocity of the boat with respect to the ground is velocity of the boat with respect to the water plus velocity of the water with respect to the ground. In short, there are just two vectors here. You can see the boat moving that way, heading due north, and the local ocean current is 1.5 meter per second in a direction 40 degrees north of east. So that's the east. So this must be 40 degrees. So the ship is going due north, the water is taking it this way, and therefore the sum of the two vectors would be along this. That's all. Seven and 1.5. And now you break it up into velocity of the boat with respect to the ground. We're taking the x components now. And remember that on this test, you do not worry too much about these problems. Just try to understand them. And along the y, again the two components along the y 7 and 1.5 sine 40. So you have those two velocities. And to find the resultant, you take sum of the squares of the velocities, which is 1.149 squared plus 7.964 squared, and you get 8.05 meter per second. And to find the angle, tan inverse VBGY. In fact, tan inverse is the y component by the x, and I've labeled it right now. So that would be tan inverse 7.964 divided by 1.149, which gives 81.8 degrees north of east. Look at this. Isn't this north of east? Yeah. So you get an angle as 81.8 degrees. north of east. And those are the problems.